How it works. Battery-powered cars. Electric cars powered by batteries are becoming increasingly popular as a cleaner and more sustainable alternative to traditional gasoline-powered cars. In this article, we will explore the mechanics behind how electric cars work and the advantages and challenges associated with their use. Electric cars are powered by electric motors, which are driven by batteries. These batteries store electrical energy, which is used to power the motor and turn the wheels. The batteries are typically made up of multiple cells, each of which contains two electrodes, a cathode and an anode, separated by a separator. The electrodes are typically made of materials such as lithium, cobalt, and nickel, which are capable of storing and releasing electrical energy. When the driver presses the accelerator pedal, electrical energy is sent from the battery to the motor, causing it to turn. This rotation is then transferred to the wheels, causing the car to move forward. Unlike gasoline-powered cars, electric cars do not produce any emissions when they are being driven, making them much more environmentally friendly. One of the biggest advantages of electric cars is their energy efficiency. Electric cars convert a much higher percentage of the energy stored in their batteries into forward motion than gasoline-powered cars, which lose a significant amount of energy through heat and other forms of waste. This means that electric cars can travel much further on a single charge than gasoline-powered cars can on a tank of gas. Another advantage of electric cars is their lower maintenance requirements. Because they have fewer moving parts than gasoline-powered cars, electric cars require less maintenance and are less prone to breaking down. This can result in significant cost savings over the life of the car. However, there are also some challenges associated with the use of electric cars. One of the biggest challenges is the limited range of the batteries. While many electric cars can travel up to 200 to 300 miles on a single charge, this is still significantly less than the range of many gasoline-powered cars. This can make long-distance travel more challenging, as drivers may need to stop and recharge their cars more frequently. Another challenge is the availability of charging infrastructure. While there are now many public charging stations available, they are still not as plentiful as gas stations, which can make it difficult for drivers to find a convenient place to recharge their cars. Additionally, charging times can be much longer than the time it takes to fill up a gas tank, which can be inconvenient for drivers. In conclusion, electric cars offer a cleaner and more sustainable alternative to traditional gasoline-powered cars. They operate using electric motors powered by batteries, which store and release electrical energy. While there are challenges associated with the use of electric cars, such as limited range and charging infrastructure, their energy efficiency and lower maintenance requirements make them an attractive option for many drivers. As technology continues to evolve, we can expect to see even more advances in the mechanics and operation of electric cars, making them an even more viable option for drivers around the world. Electric cars powered by batteries have come a long way in recent years, with advances in technology resulting in greater energy efficiency, longer ranges, and faster charging times. In this article, we will delve deeper into the mechanics behind how electric cars work, and the latest innovations and trends in the electric car industry. As previously mentioned, electric cars are powered by electric motors that are powered by batteries. These batteries typically use lithium-ion technology, which is capable of storing large amounts of energy in a lightweight and compact package. The battery pack is the most expensive component of an electric car and accounts for a significant portion of the vehicle's overall cost. To recharge the battery, electric cars can be plugged into a charging station, which can be found at public charging stations or at home. There are several different types of charging stations, ranging from level 1 chargers that can take up to 24 hours to fully recharge a battery, to level 3 chargers that can recharge a battery to 80% in as little as 30 minutes. One of the latest trends in the electric car industry is the development of electric cars with longer ranges. In recent years, several electric car manufacturers have released models with ranges of over 300 miles on a single charge. This has been made possible through advances in battery technology, as well as improvements in the aerodynamics and efficiency of electric cars. Another trend in the electric car industry is the development of fast charging technology. This technology allows electric cars to be recharged in as little as 10 to 15 minutes, making it much more convenient for drivers to recharge their cars while on long trips. However, fast charging technology is still in the early stages of development, and there are concerns about the impact that fast charging can have on the long-term health of the battery. In addition to these trends, there are also several other innovations in the electric car industry that are worth noting. For example, several electric car manufacturers are experimenting with wireless charging technology, which would allow electric cars to be recharged without the need for a physical connection to a charging station. There are also developments in the use of solid-state batteries, which are lighter and more energy-dense than traditional lithium-ion batteries. In conclusion, electric cars powered by batteries are becoming an increasingly viable alternative to traditional gasoline-powered cars. They operate using electric motors powered by batteries, which are capable of storing large amounts of energy in a compact package. As technology continues to evolve, we can expect to see even more innovations and trends in the electric car industry, making electric cars an even more attractive option for drivers around the world. Electric cars powered by batteries are transforming the automotive industry, with many countries setting ambitious goals to phase out gasoline-powered cars in favor of electric cars in the coming years. In this article, we will explore the benefits and challenges associated with the widespread adoption of electric cars, and what the future holds for the electric car industry. One of the biggest benefits of electric cars is their environmental impact. Electric cars produce zero emissions while being driven, which can significantly reduce air pollution and greenhouse gas emissions. This is particularly important in urban areas, where air pollution is a major health concern. Additionally, electric cars can be powered by renewable energy sources such as wind and solar power, making them even more environmentally friendly. Another benefit of electric cars is their lower operating costs. Electric cars are much more energy efficient than gasoline-powered cars, which means they require less fuel to travel the same distance. Additionally, electric cars require less maintenance than gasoline-powered cars, which can result in significant cost savings over the life of the car. However, there are also challenges associated with the widespread adoption of electric cars. The invention of the computer. The development of computers can be traced back to the 19th century, when inventors such as Charles Babbage and Ada Lovelace began exploring the possibilities of mechanical computation. Over the years, a number of key innovations and breakthroughs have contributed to the development of the modern computer, transforming it from a complex and specialized machine to an integral part of daily life. One of the key early innovations in the development of computers was the invention of the binary system by Gottfried Wilhelm Leibniz in the 17th century. The binary system uses only two digits, 0 and 1, to represent numbers and perform calculations. This system formed the basis for the development of modern computers, which use binary code to represent all types of data. Another important development in the history of computers was the invention of the first programmable computer, the analytical engine, by Charles Babbage in the 19th century. Although this machine was never completed, it laid the groundwork for the development of modern computers, with its use of punch cards and stored programs. In the early 20th century, a number of key innovations contributed to the development of the modern computer. These included the invention of the vacuum tube by Lee de Forest, which enabled the development of electronic amplifiers and led to the creation of the first electronic computers. During World War II, computers were developed for military applications, such as code breaking and ballistics calculations. The development of the first electronic digital computer, the ENIAC, in 1946, marked a major milestone in the history of computing. This machine used vacuum tubes to perform calculations at a speed that was previously unimaginable. In the years that followed, a number of key innovations contributed to the development of the modern computer, including the invention of the transistor by William Shockley, John Bardeen, and Walter Brattain in 1947. The transistor revolutionized the electronics industry, enabling the development of smaller, faster, and more reliable computers. The invention of the microprocessor by Intel in 1971 marked another major breakthrough in the history of computing. The microprocessor enabled the development of smaller, more affordable computers, paving the way for the development of personal computers and the computer revolution of the 1980s and 1990s. Today, computers are an integral part of daily life, used for everything from communication and entertainment to scientific research and industrial production. The development of computers has transformed the way we live, work, and connect with one another and continues to shape the world around us. In conclusion, the development of computers has been a long and complex process, marked by a number of key innovations and breakthroughs. From the invention of the binary system to the development of the microprocessor, each new development has contributed to the evolution of the modern computer, transforming it from a specialized machine to an essential tool for modern life. With continued innovation and development, the future of computing is sure to be even more exciting and transformative than its past. The development of computers has been a long and fascinating process, marked by numerous key innovations and breakthroughs. One of the most significant breakthroughs in computing was the development of the integrated circuit, IC, in the late 1950s. The IC revolutionized the electronics industry by enabling the production of smaller, faster, and more reliable computers. The IC was invented independently by two researchers, Jack Kilby of Texas Instruments and Robert Noyce of Fairchild Semiconductor. Kilby's invention was based on the use of a single piece of semiconductor material, while Noyce's invention used a process called planar technology to create a flat surface for the IC. The IC was a major breakthrough because it allowed for the integration of multiple electronic components onto a single piece of silicon. This enabled the development of smaller and more powerful computers, which became widely used in a variety of applications, including military, industrial, and consumer electronics. Another important breakthrough in the development of computers was the invention of the Graphical User Interface, GUI, in the 1970s. The GUI was developed by researchers at Xerox PARC, including Alan Kay, Douglas Engelbart, and Steve Jobs. The GUI made computers more user-friendly by allowing users to interact with graphical elements, such as icons and windows, rather than typing text-based commands. The development of the GUI was a major milestone in the history of computing because it enabled the widespread adoption of personal computers. With the introduction of the Apple Macintosh in 1984, the GUI became a standard feature of personal computers, revolutionizing the way people interacted with computers and paving the way for the development of modern operating systems. In recent years, the development of cloud computing has had a major impact on the way computers are used and managed. Cloud computing enables users to access computing resources, such as storage and processing power, over the Internet, rather than relying on local hardware. This has led to the development of new applications and services, such as social media, online gaming, and e-commerce, as well as new approaches to data storage and management. In conclusion, the development of computers has been shaped by a number of key innovations and breakthroughs, including the integrated circuit, the graphical user interface, and cloud computing. These innovations have transformed the way we use and interact with computers, enabling new applications and services and driving innovation in a range of industries. With continued investment in research and development, the future of computing is sure to be even more exciting and transformative than its past. The development of computers has been a fascinating journey, marked by numerous key innovations and breakthroughs. One of the most significant breakthroughs in computing was the development of the Internet in the 1960s. Initially developed as a way for researchers to communicate and share information, the Internet has since become a global network connecting billions of people and devices around the world. The development of the Internet was driven by a number of key innovations, including the creation of the packet switching technology by researchers at the Massachusetts Institute of Technology, MIT, in the late 1960s. Packet switching enabled the transmission of data over a network in small, discrete packets, rather than as a continuous stream. This made it possible to send data across long distances more efficiently and reliably. Another important breakthrough in the development of the Internet was the invention of the World Wide Web, WWW, in the 1980s by Tim Berners-Lee. The WWW made it possible for users to access and share information over the Internet using a standard set of protocols, including HTTP and HTML. This led to the development of new applications and services, such as search engines, social media, and e-commerce, and transformed the way people interacted with the Internet. In recent years, the development of artificial intelligence, AI, has had a major impact on the way computers are used and managed. AI enables computers to perform tasks that would normally require human intelligence, such as recognizing speech, identifying objects, and making decisions. This has led to the development of new applications and services, such as virtual assistants, self-driving cars, and predictive analytics, as well as new approaches to data processing and analysis. The development of AI has also raised important ethical and social issues, such as the impact on employment and the potential for bias and discrimination in decision-making. As AI continues to evolve and become more sophisticated, it will be important to ensure that it is developed and used in a responsible and ethical manner. In conclusion, the development of computers has been shaped by a number of key innovations and breakthroughs, including the Internet, the World Wide Web, and artificial intelligence. How electric cars work. Electric cars are becoming an increasingly popular alternative to traditional gasoline-powered cars due to their environmental benefits and lower operating costs. In this article, we will explore the mechanics behind how electric cars work and the different types of electric cars available. Electric cars are powered by electric motors that are driven by batteries. These batteries store electrical energy, which is used to power the motor and turn the wheels. The batteries are typically made up of multiple cells, each of which contains two electrodes, a cathode and an anode, separated by a separator. The electrodes are typically made of materials such as lithium, cobalt, and nickel, which are capable of storing and releasing electrical energy. When the driver presses the accelerator pedal, electrical energy is sent from the battery to the motor, causing it to turn. This rotation is then transferred to the wheels, causing the car to move forward. Unlike gasoline-powered cars, electric cars do not produce any emissions when they are being driven, making them much more environmentally friendly. There are several different types of electric cars available, each with its own unique features and benefits. The most common types of electric cars are battery electric vehicles, BEVs, plug-in hybrid electric vehicles, PHEVs, and hybrid electric vehicles, HEVs. Battery electric vehicles, BEVs, are powered solely by batteries and do not have a gasoline engine. They must be plugged in to recharge and typically have a range of between 100 to 300 miles on a single charge. Plug-in hybrid electric vehicles, PHEVs, have both a battery and a gasoline engine. They can be plugged in to recharge the battery, but the gasoline engine can also be used to power the car when the battery is depleted. PHEVs typically have a range of between 30 to 50 miles on a single charge. Hybrid electric vehicles, HEVs, also have both a battery and a gasoline engine, but the battery is charged by the gasoline engine rather than by plugging in. HEVs typically have a range of between 400 to 600 miles on a single tank of gas. In addition to these types of electric cars, there are also several other types of electric vehicles, including electric motorcycles, electric scooters, and electric bicycles. In conclusion, electric cars are powered by electric motors that are driven by batteries, which store electrical energy. There are several different types of electric cars available, each with its own unique features and benefits. As technology continues to evolve and charging infrastructure becomes more widespread, we can expect to see even more growth in the electric car industry in the coming years. Electric cars have become increasingly popular in recent years due to their environmental benefits and lower operating costs. In this article, we will delve deeper into the mechanics behind how electric cars work and the advantages and disadvantages of using electric cars. Electric cars are powered by electric motors, which are driven by batteries. The batteries store electrical energy, which is used to power the motor and turn the wheels. The batteries used in electric cars are typically made up of multiple cells, each of which contains two electrodes separated by a separator. When the driver presses the accelerator pedal, electrical energy is sent from the battery to the motor, causing it to turn. This rotation is then transferred to the wheels, causing the car to move forward. One of the biggest advantages of electric cars is their environmental impact. Electric cars produce zero emissions while being driven, which can significantly reduce air pollution and greenhouse gas emissions. This is particularly important in urban areas, where air pollution is a major health concern. Additionally, electric cars can be powered by renewable energy sources such as wind and solar power, making them even more environmentally friendly. Another advantage of electric cars is their lower operating costs. Electric cars are much more energy efficient than gasoline-powered cars, which means they require less fuel to travel the same distance. Additionally, electric cars require less maintenance than gasoline-powered cars, which can result in significant cost savings over the life of the car. However, there are also disadvantages associated with electric cars. One of the biggest disadvantages is the cost of electric cars. While the cost of electric cars has been declining in recent years, they are still more expensive than gasoline-powered cars. This is due in part to the high cost of battery technology, which is the most expensive component of an electric car. Charging infrastructure is another disadvantage of electric cars. While there are now many public charging stations available, they are still not as plentiful as gas stations, which can make it difficult for drivers to find a convenient place to recharge their cars. Additionally, charging times can be much longer than the time it takes to fill up a gas tank, which can be inconvenient for drivers. In conclusion, electric cars are powered by electric motors that are driven by batteries, which store electrical energy. While electric cars have many advantages, such as their environmental impact and lower operating costs, there are also disadvantages, such as their higher cost and charging infrastructure. As technology continues to evolve and charging infrastructure becomes more widespread, we can expect to see even more growth in the electric car industry in the coming years. Electric cars are revolutionizing the automotive industry by providing a cleaner and more sustainable alternative to traditional gasoline-powered cars. In this article, we will discuss the latest developments in the electric car industry, including advancements in battery technology, charging infrastructure, and autonomous driving technology. One of the most exciting developments in the electric car industry is advancements in battery technology. Battery technology has been one of the biggest barriers to the adoption of electric cars due to the high cost and limited range of batteries. However, recent advancements in battery technology, such as solid-state batteries, are expected to significantly increase the range of electric cars while reducing their cost. Another important development in the electric car industry is the expansion of charging infrastructure. While there are now many public charging stations available, they are still not as plentiful as gas stations, which can make it difficult for drivers to find a convenient place to recharge their cars. However, several major car manufacturers and governments are investing in expanding charging infrastructure, which is expected to make electric cars more convenient and accessible for drivers. Autonomous driving technology is another important development in the electric car industry. Electric cars are well suited for autonomous driving, as their electric motors provide instant torque and smooth acceleration, which can make for a more comfortable and efficient ride. Autonomous driving technology can also help to reduce traffic congestion and improve road safety. Despite these exciting developments, there are still challenges associated with the widespread adoption of electric cars. One of the biggest challenges is the cost of electric cars, which can be significantly higher than gasoline-powered cars. Additionally, there are concerns about the availability of charging infrastructure, particularly in rural areas where public charging stations may be less common. Inside the drone. Unmanned aerial vehicles, UAVs, commonly known as drones, have become increasingly popular for a wide range of applications, including military, commercial, and recreational purposes. Inside the unmanned aerial vehicle, there are several key components that enable it to fly and carry out its mission. First, there is the flight control system, which is responsible for controlling the movement and stability of the drone. The flight control system includes sensors, such as accelerometers and gyroscopes, which detect changes in the drone's position and orientation, as well as a flight controller that processes this information and sends commands to the drone's motors. Second, there is the propulsion system, which is responsible for providing the necessary thrust to lift the drone off the ground and keep it in the air. The propulsion system typically consists of electric or gas-powered motors, which are connected to the drone's propellers or rotors. Third, there is the communication system, which allows the drone to send and receive data and commands. The communication system includes an onboard computer, which can be programmed to carry out specific tasks, as well as a radio transmitter and receiver, which enable the drone to communicate with a ground control station or other drones. Fourth, there is the payload, which is the equipment or sensors that are carried by the drone to carry out its mission. The payload can include cameras, sensors for detecting temperature, humidity, or other environmental factors, and even weapons or other specialized equipment. Finally, there is the power supply, which provides the necessary energy to power the drone's components. The power supply can be a battery or fuel cell, depending on the size and type of the drone. Overall, the components inside an unmanned aerial vehicle work together to enable it to fly, carry out its mission, and communicate with its operators or other drones. As technology continues to advance, it is likely that drones will become even more sophisticated and capable, with a wider range of applications and uses. However, it is important to ensure that drones are used safely and responsibly, with appropriate regulations and safeguards in place to protect privacy and prevent accidents or misuse. In addition to the components inside an unmanned aerial vehicle, there are several other factors that are important to consider when operating a drone. These include the regulations and guidelines that govern the use of drones, as well as the potential risks and challenges associated with drone operations. Regulations and guidelines for drone operations vary depending on the country and region, but generally include requirements for registration, pilot certification, and adherence to safety and privacy guidelines. It is important for drone operators to be aware of these regulations and guidelines and to follow them closely to ensure safe and responsible drone operations. One of the potential risks associated with drone operations is the risk of collisions with other aircraft, such as manned aircraft or other drones. To mitigate this risk, many countries have established regulations for drone operations, such as requiring drones to fly below a certain altitude. stay away from airports, and avoid other restricted airspace. Another potential risk associated with drone operations is the risk of accidents or crashes, which can cause property damage or personal injury. To mitigate this risk, it is important for drone operators to undergo proper training and certification, and to follow safety guidelines, such as conducting pre-flight checks and maintaining a safe distance from people and property. In addition to these risks, there are also challenges associated with drone operations, such as limited flight time and range, and the need for specialized equipment and software to operate and maintain the drone. As technology continues to advance, it is likely that these challenges will be addressed and overcome, leading to even more widespread use and applications for drones. Overall, the use of unmanned aerial vehicles has the potential to revolutionize a wide range of industries and applications, from shipping and logistics to search and rescue operations. However, it is important to ensure that drones are used safely and responsibly, with appropriate regulations and safeguards in place to protect privacy and prevent accidents or misuse. With continued innovation and development, the future of drones is sure to be even more exciting and transformative than its past. In addition to the risks and challenges associated with drone operations, there are also many potential benefits of using unmanned aerial vehicles, UAVs. One of the most significant benefits is the ability to collect and analyze data from a bird's-eye view. Drones equipped with high-resolution cameras and sensors can capture detailed images and data about the environment, which can be used for a wide range of applications, such as mapping and surveying, agriculture, and environmental monitoring. Another benefit of using drones is their ability to access remote or hazardous locations that may be difficult or dangerous for humans to reach. UAVs are increasingly being used for search and rescue operations, as well as for inspecting infrastructure such as bridges, power lines, and oil rigs. In the military, drones are being used for surveillance, reconnaissance, and targeted strikes. The use of drones in military operations has the potential to reduce the risk of casualties, as well as to provide real-time intelligence to troops on the ground. The use of drones in the commercial sector is also on the rise, with applications ranging from package delivery and transportation to photography and videography. Companies such as Amazon and Google are developing drone delivery systems that could revolutionize the way goods are transported and delivered. In addition to these potential benefits, the development of drones is also driving innovation in a number of related areas, such as battery technology, miniaturization, and artificial intelligence. As drones become more sophisticated and capable, they are likely to continue to drive innovation and transform a wide range of industries. However, it is important to ensure that the use of drones is regulated and monitored to prevent accidents and misuse. This includes adherence to safety guidelines and regulations, as well as the development of technologies to prevent collisions and other accidents. Overall, the use of unmanned aerial vehicles has the potential to transform a wide range of industries and applications, from shipping and logistics to search and rescue operations. With continued innovation and development, the future of drones is sure to be even more exciting and transformative than its past. Besides the benefits and challenges of using drones, there are also ethical considerations to take into account. One of the main ethical concerns is the potential invasion of privacy. Drones equipped with cameras and sensors can collect sensitive information about people and properties, and the widespread use of drones could pose a threat to personal privacy. It is important to establish guidelines and regulations to ensure that the use of drones does not violate people's privacy rights. Another ethical concern is the use of drones in military operations. While the use of drones can reduce the risk of casualties for military personnel, it also raises concerns about the morality of using unmanned vehicles to carry out targeted strikes. The use of drones in warfare raises questions about accountability, transparency, and the potential for unintended consequences. There are also concerns about the impact of drones on the environment. The use of drones for transportation and delivery could lead to increased air traffic and carbon emissions, which could have negative impacts on the environment. It is important to consider the environmental impact of drone operations and to develop technologies to minimize their carbon footprint. Discover the manufacturing process data collection and analysis technology. Data collection and analysis technology has revolutionized the way businesses operate and make decisions. In this article, we will explore the process of creating data collection and analysis technology, including the tools and techniques used to gather and analyze data. The first step in creating data collection and analysis technology is to identify the data that needs to be collected. This could include customer data, sales data, website analytics, social media data, and more. Once the data has been identified, the next step is to determine the best method for collecting it. This could involve surveys, online forms, data scraping, or other methods. Once the data has been collected, it is important to store it in a way that is easy to access and analyze. This is where data management systems come into play. Data management systems are software programs that allow businesses to store, organize, and manage their data. These systems can be customized to meet the specific needs of a business, and can include features such as data visualization tools, data analytics, and machine learning algorithms. After the data has been collected and stored, the next step is to analyze it. Data analysis involves using statistical techniques and algorithms to extract insights and patterns from the data. This can be done using a variety of tools, including Excel spreadsheets, SQL databases, and specialized data analysis software. Data analysts and scientists use these tools to identify trends, make predictions, and inform business decisions. One of the biggest challenges in data analysis is dealing with large amounts of data. This is where big data technology comes into play. Big data technology is designed to handle massive amounts of data, which can be difficult to analyze using traditional data analysis techniques. Big data technology includes tools such as Hadoop, Spark, and NoSQL databases, which are designed to handle data storage and processing at scale. Another important aspect of data collection and analysis technology is data security. With the increasing amount of data being collected and stored, it is important to ensure that this data is secure and protected from unauthorized access. This can involve using encryption, firewalls, and other security measures to protect sensitive data. In conclusion, data collection and analysis technology has revolutionized the way businesses operate and make decisions. The process of creating data collection and analysis technology involves identifying the data that needs to be collected, determining the best method for collecting it, storing it in a way that is easy to access and analyze, and using statistical techniques and algorithms to extract insights and patterns from the data. With the increasing amount of data being collected, it is important to ensure that this data is secure and protected from unauthorized access. As technology continues to evolve, we can expect to see even more advanced data collection and analysis tools and techniques in the future. Data collection and analysis technology is a crucial component of modern businesses, helping them to make informed decisions and gain a competitive edge. In this article, we will delve deeper into the process of creating data collection and analysis technology, including the challenges and opportunities that come with it. The first step in creating data collection and analysis technology is to establish clear objectives for the data collection process. This involves defining the problem to be solved, the questions to be answered, and the data sources required. Once the objectives are established, the next step is to determine the most effective methods for collecting and managing data. Data collection can be done through various methods such as surveys, interviews, online forms, sensors, and more. It is crucial to ensure that the data collected is accurate, reliable, and relevant to the objectives. Data management systems are used to organize, store, and retrieve data efficiently. These systems are designed to handle various types of data, including structured, unstructured, and semi-structured data. Data analysis is the process of analyzing, interpreting, and deriving insights from the collected data. Data analysis is done using various techniques such as statistical analysis, data mining, machine learning, and predictive modeling. Data analysts use these techniques to identify patterns, trends, and relationships within the data. This helps businesses to make informed decisions, optimize their operations, and improve their products and services. One of the biggest challenges in data collection and analysis is the issue of data privacy and security. With the increasing amount of data being collected, it is important to ensure that the data is protected from unauthorized access, misuse, and theft. Businesses are required to comply with data privacy regulations such as GDPR, CCPA, and HIPAA, which mandate strict rules for data handling and protection. Another challenge is the issue of data quality. Poor data quality can lead to inaccurate insights and incorrect decisions. Data quality can be affected by various factors such as data entry errors, missing data, duplicate data, inconsistent data, and more. Data cleansing and data validation techniques are used to improve data quality and ensure accuracy. In conclusion, data collection and analysis technology is a critical tool for businesses seeking to gain a competitive advantage. The process of creating data collection and analysis technology involves establishing clear objectives, determining the most effective methods for collecting and managing data, analyzing and interpreting the data, and ensuring data privacy and security. By leveraging the power of data, businesses can make informed decisions, improve their operations, and provide better products and services to their customers. As technology continues to advance, we can expect to see even more sophisticated data collection and analysis tools and techniques in the future. Data collection and analysis technology has become increasingly important in today's digital age, as businesses rely on data to make informed decisions and gain a competitive advantage. In this article, we will explore the benefits and challenges of data collection and analysis technology, as well as the role it plays in modern business. One of the primary benefits of data collection and analysis technology is its ability to provide valuable insights into customer behavior, preferences, and trends. By collecting and analyzing data from various sources such as social media, website analytics, and customer surveys, businesses can gain a better understanding of their customers and tailor their products and services accordingly. This can lead to increased customer satisfaction, loyalty, and revenue. Another benefit of data collection and analysis technology is its ability to improve operational efficiency. By analyzing data from various sources such as supply chains, production lines, and logistics, businesses can identify areas for improvement and optimize their operations. This can lead to cost savings, increased productivity, and better resource allocation. How 3D printer works. 3D printing technology has revolutionized the way we manufacture and create products. With 3D printers, it is possible to create complex shapes and structures with a high degree of precision and accuracy. In this article, we will explore the workings of 3D printers and the process of 3D printing. At its core, 3D printing is a process of additive manufacturing. This means that the printer builds an object layer by layer, adding material until the final product is complete. The material used in 3D printing can vary depending on the printer and the application, but some common materials include plastics, metals, and ceramics. The process of 3D printing begins with a digital design file. This design file is created using 3D modeling software or obtained from an online repository. The design file is then loaded into the 3D printer software, which slices the design into thousands of layers. Once the design is sliced, the printer begins to build the object layer by layer. The printer head moves back and forth along the X and Y axes, depositing material to create each layer. As each layer is completed, the printer bed moves down slightly, allowing the printer to build the next layer on top of the previous layer. One of the key advantages of 3D printing is its ability to create complex shapes and structures that would be difficult or impossible to manufacture using traditional manufacturing methods. For example, 3D printing can create objects with internal cavities or intricate geometries, which would be difficult to create using other methods. Another advantage of 3D printing is its flexibility and versatility. 3D printers can be used to create a wide range of objects, from small parts and prototypes to large-scale structures such as buildings and bridges. However, there are also some limitations to 3D printing technology. One limitation is the size of the printer bed, which limits the size of objects that can be printed. Another limitation is the speed of printing, which can be slower than other manufacturing methods. To overcome these limitations, researchers and engineers are constantly developing new methods and technologies to improve the speed and capabilities of 3D printing. Some of these advances include faster printing speeds, larger printer beds, and new materials such as biodegradable plastics and composites. In conclusion, 3D printing is an innovative and exciting technology with a wide range of applications. By understanding the workings of 3D printers and the process of 3D printing, we can better appreciate the potential of this technology and its impact on manufacturing, design, and engineering. As 3D printing technology continues to advance, it is likely that we will see even more groundbreaking and transformative applications of this technology in the years to come. In addition to the working principle and advantages of 3D printing, there are several factors that are important to consider when operating a 3D printer. These include the types of 3D printers available, the materials that can be used, and the software and hardware needed to operate a 3D printer. There are several types of 3D printers available, including fused deposition modeling, FDM, stereolithography, SLA, and selective laser sintering, SLS. Each type of printer has its own advantages and disadvantages, and the choice of printer will depend on the specific application and requirements. The materials used in 3D printing can vary depending on the printer and the application. Some common materials used in 3D printing include plastics, metals, and ceramics. There are also specialized materials available, such as conductive materials, flexible materials, and biocompatible materials. To operate a 3D printer, it is important to have the necessary software and hardware. The software needed to operate a 3D printer includes design software for creating the digital design files, as well as slicing software for preparing the design for printing. The hardware needed to operate a 3D printer includes the printer itself, as well as any necessary accessories such as a filament spool holder, a build plate, and a cooling fan. One of the challenges associated with 3D printing is the need for post-processing, which involves removing support structures, sanding or polishing the finished object, and applying a finishing coat if necessary. Post-processing can be time-consuming and labor-intensive, but it is an important step in creating a high-quality finished product. Another challenge associated with 3D printing is the cost of equipment and materials. While the cost of 3D printers has decreased in recent years, they are still relatively expensive compared to other manufacturing tools. The cost of materials can also be high, particularly for specialized or exotic materials. Despite these challenges, the benefits of 3D printing are clear. 3D printing has revolutionized manufacturing and design, and has the potential to transform a wide range of industries, from healthcare to aerospace. As 3D printing technology continues to advance, it is likely that we will see even more innovative and transformative applications of this technology in the future. In conclusion, 3D printing is a powerful and versatile technology with a wide range of applications. By understanding the types of printers available, the materials that can be used, and the software and hardware needed to operate a 3D printer, we can better appreciate the potential of this technology and its impact on manufacturing, design, and engineering. With continued innovation and development, the future of 3D printing is sure to be even more exciting and transformative than its past. In addition to the benefits and challenges of 3D printing, there are also ethical considerations to take into account when operating a 3D printer. One of the main ethical concerns is the potential for copyright infringement and intellectual property theft. 3D printers can be used to create replicas of existing products, which could potentially infringe on the intellectual property rights of the original creator. It is important to ensure that 3D printing is used in a responsible and ethical manner, and to respect the intellectual property rights of others. Another ethical concern is the potential for 3D printing to exacerbate existing social and economic inequalities. 3D printing technology has the potential to democratize manufacturing and make it more accessible to individuals and small businesses. However, there is also the potential for large corporations to use 3D printing technology to further consolidate their power and control over the market. It is important to consider the potential impact of 3D printing technology on society and to develop strategies to promote equitable access and distribution of the technology. There are also environmental considerations associated with 3D printing. 3D printing can be a more sustainable manufacturing method than traditional manufacturing methods, such as injection molding or CNC machining, as it generates less waste and can use recycled materials. However, the production and disposal of 3D printing materials can still have an environmental impact, particularly if the materials are not recycled or disposed of properly. The story of the invention of the intelligent control system. The story of the invention of smart control systems is a fascinating one, as it involves the convergence of multiple technologies and disciplines. In this article, we will explore the history of smart control systems, including the key players and advancements that led to their creation. The concept of smart control systems can be traced back to the early 20th century, when the first remote controls were developed for televisions and radios. These early controls used infrared technology to transmit signals, allowing users to change channels and adjust the volume without having to physically touch the device. In the 1960s, the first home automation systems were introduced, allowing homeowners to control various aspects of their home such as lighting, temperature, and security. These systems were usually controlled by a central unit that communicated with various sensors and actuators throughout the home. The real breakthrough in smart control systems came in the 1980s with the development of the first programmable logic controllers, PLCs. These devices were used to control industrial processes and were capable of processing large amounts of data and making decisions based on that data. In the 1990s, the rise of the Internet and wireless communication technologies led to the development of more advanced smart control systems. These systems were capable of connecting to the Internet and communicating with other devices, allowing for remote control and monitoring. Today, smart control systems are used in a wide range of industries, from manufacturing and transportation to healthcare and home automation. These systems use a combination of sensors, actuators, and software to collect data, analyze it, and make decisions based on that data. One of the key advancements in smart control systems is the use of artificial intelligence, AI, and machine learning. These technologies allow smart control systems to learn from past data and make predictions about future events. This can lead to more efficient and effective control of processes and systems. Another advancement is the use of blockchain technology to improve security and transparency in smart control systems. Blockchain technology allows for a decentralized, tamper-proof ledger of transactions, which can be used to track and verify data in real time. In conclusion, the story of smart control systems is one of continuous innovation and advancement. From the early remote controls of the 20th century to the AI-powered systems of today, smart control systems have come a long way. With the rapid pace of technological advancement, we can expect to see even more sophisticated and effective smart control systems in the future, transforming the way we live and work. The development of smart control systems has revolutionized the way we interact with technology, enabling us to control and monitor various systems and processes from a distance. In this article, we will delve deeper into the benefits and challenges of smart control systems, as well as the key trends shaping their future. One of the primary benefits of smart control systems is their ability to increase efficiency and productivity. By automating processes and systems, smart control systems reduce the need for manual intervention and can optimize the use of resources. This can lead to cost savings, increased productivity, and improved customer satisfaction. Another benefit of smart control systems is their ability to improve safety and security. By monitoring and controlling various systems and processes, smart control systems can detect and respond to potential hazards and security threats. This can help to prevent accidents, reduce the risk of damage or loss, and improve overall safety and security. However, there are also challenges associated with smart control systems. One of the biggest challenges is the issue of interoperability. Smart control systems often use different protocols and standards, which can make it difficult to integrate them with other systems and devices. This can lead to siloed systems and data, which can limit their effectiveness. Another challenge is the issue of data privacy and security. With the increasing amount of data being collected and transmitted by smart control systems, it is important to ensure that the data is protected from unauthorized access, misuse, and theft. Businesses are required to comply with data privacy regulations such as GDPR, CCPA, and HIPAA, which mandate strict rules for data handling and protection. To address these challenges, businesses need to invest in interoperability standards and data governance frameworks. Interoperability standards such as MQTT, OPQA, and RESTful APIs are designed to enable communication and data exchange between different systems and devices. Data governance frameworks are designed to manage the availability, integrity, and security of data used in an organization. Looking to the future, there are several key trends shaping the development of smart control systems. One trend is the increasing use of edge computing, which involves processing data at the edge of the network rather than sending it to a centralized data center. This can reduce latency, improve performance, and enhance security. Another trend is the integration of AI and machine learning, which can enable smart control systems to make more accurate predictions and decisions based on past data. This can lead to more efficient and effective control of processes and systems. In conclusion, smart control systems have transformed the way we interact with technology, enabling us to control and monitor various systems and processes from a distance. While there are challenges associated with smart control systems, such as interoperability and data privacy, businesses can address these challenges by investing in interoperability standards and data governance frameworks. With the rapid pace of technological advancement, we can expect to see even more sophisticated and effective smart control systems in the future. Smart control systems have become increasingly prevalent in today's digital age, providing businesses with a wide range of benefits including increased efficiency, productivity, and safety. In this article, we will explore some of the key applications of smart control systems across different industries, including manufacturing, healthcare, and transportation. Manufacturing is one of the industries that has seen significant benefits from the use of smart control systems. Smart control systems are used to automate processes and systems, reducing the need for manual intervention and optimizing the use of resources. This can lead to cost savings, increased productivity, and improved product quality. Smart control systems are also used to monitor and analyze data in real time, enabling manufacturers to make informed decisions about process improvements and resource allocation. In healthcare, smart control systems are used to monitor and control various aspects of patient care, including medication administration, vital signs monitoring, and patient movement. Smart control systems can help to improve patient outcomes by reducing the risk of medication errors, preventing falls, and improving the overall quality of care. Smart control systems are also used to manage the flow of patients through hospitals and clinics, optimizing the use of resources and reducing wait times. In transportation, smart control systems are used to control and monitor various systems and processes, including traffic signals, vehicle routing, and maintenance schedules. Smart control systems can help to reduce traffic congestion, improve safety, and optimize the use of resources. For example, smart traffic control systems can adjust traffic signals in real time based on traffic flow, reducing the time drivers spend waiting at red lights and improving overall traffic flow.